means that you turn the sine wave on and off, just like the IT guy suggested. Doing this allows you to easily send Morse code, but that's just about it. Pulse modulation is rarely used except to control clocks across the US. The simplicity of pulse modulation also allows one pulse modulator to cover massive areas, like the entire US. Amplitude modulation, on the other hand, is what is utilized by AM radio stations and TV signals to encode data. In this format, the amplitude, or peak-to-peak voltage of the wave, is changed. You can imagine this as the wave from a person's voice being combined with a sine wave to create a new, rather complex sine wave with the same frequency, but with a lot more data inside. Finally, frequency modulation, otherwise known as FM, is used for FM radio and tons of other wireless tech. In this encoding technique, the sine wave frequency changes slightly based on the signal. This means that the distance between the peaks of the waves is varied based on the data that's trying to be transmitted. Bringing all of these different techniques back into the real world, we can begin to understand them a little further. If you sit in your car and tune your radio to AM 680, that means that the transmitting station was operating at 680,000 hertz, meaning that the sine wave repeats 680,000 times per second. The voice of the speaker or the music on the transmitting side is modulated onto that wave through amplitude modulation. Then, the signal is amplified up to 50,000 watts for larger AM radio stations and then sent into space utilizing the antenna. Your car's radio picks up that signal, utilizing its own antenna. This can be as simple as a wire or a metal stick. In conjunction with the tuner on your radio tuning to the specific frequency, the tuner starts resonating at 680 kilohertz. Called resonance, this principle allows the radio to essentially ignore any other signals in the air. The signal then passes to the detector, or demodulator, that takes the voice or music from the wave, utilizing a device called a diode, and translates it back into audio. The final step in the process is for the radio to amplify the signal so you can hear it and change the volume as needed. FM radios have different detector setups and translate frequency into sound rather than amplitude, but otherwise they operate in the same way. Data can be encoded onto a constantly changing signal utilizing different modulation techniques that have advantages and disadvantages to each method. Nearly everything that communicates wirelessly around us uses radio waves to do so, and creating your own simple radio is actually a very manageable task. Over the last century, radio has radically changed the course of humanity and rapidly accelerated the growth of the information age.
So, this gives you a basic idea about how radio works. Okay, it is same across your Wi-Fi or any other technology that uses radio. In ham radio as well, we use a similar communication where we use FM or SSB modulation. SSB is just an addition to your AM transmissions. I'll not get into those details right now, but those are the similar concept that we use for ham radio communication. So it's just like how a broadcasting station works, but we are not a broadcasting station, we are only for hobby, wherein we cannot use ham radio for commercial purposes. It's just like a sports wherein we make contacts with other ham radio operators around the world. Okay. Now we'll get into the history of ham radio and then slightly into the details of what bands do we operate and what all things we can do as a ham radio operator here.
Radio has been around in several forms since the first successful radio signal was sent by Guglielmo Marconi in the late 1800s. One of the perhaps lesser-known uses of radio is ham radio. Ham radio is purely for hobbyists. Operators are often called upon during civilian emergencies. Ham radio is effective because you don't need a power grid in place to operate it. Similar to broadcast radio stations, each ham operator was required to, after a successful communication with another ham operator, it is proper etiquette to exchange addresses and to send a special type of postcard, known as a QSL card. The cards here and the equipment too all belonged to one man. Today, ham radio is still used, mostly in emergency situations. A solitary hobby that builds bridges between people and disparate places.
Okay, so about ham radio, here like as a video talks about the QSL card. So whenever we make contacts around the world, we also send some kind of acknowledgements. Now these are called as QSL cards. Basically, they are just like postcards which we exchange with other ham radio operators. Of course, in nowadays we have internet where we can confirm our exchanges over an online QSL card. But these were the things from the past which have still remain, and many people love to collect these postcards or QSL cards. So in the front of the card we show the call sign of the operator. Now every ham radio operator has a call sign. A call sign is like the number plate of the vehicle. Like every car has a unique call sign as number plate. Similarly, a ham radio operator also has a call sign. Okay. Now this call sign is allocated to us by Government of India in India and across various governments in their respective countries. Now my call sign is VU2YQ. Okay. Similarly, any other ham in India will have a call sign beginning with VU. Okay. Like how GA is for Goa, MH is for Maharashtra. In similar terms, every country has a block of calls, the prefix of the call sign given to them. Like for example, if you are from Thailand, then it will be H and S, alphabet H for hotel, S for Sierra, so HS. Then for, it is not fixed to these characters, it's a block of characters, so they will use that. After that is over, they might use other block. Similarly for, let's say, Dubai, they will use number A6, okay, their call sign begins with alpha 6, A6. You must have seen the call sign of aeroplanes as well. On the tail of the aeroplane, if anytime you travel, or in the front of it, you will see a number plate of the of the aeroplane. It will be usually VT and then 3 characters. The next 3 characters are random, but VT is for India. That means that aircraft belongs to India. Similar concept applies for ham radio call signs as well. So here we have this QSL card that we exchange with other ham radio operators. Now, for example, this card has come from Antarctica. Of course, there are some ham radio operators in Antarctica, but it's not a permanent habitat. There are scientists from all over the world who do research there, and in that free time, they also make contacts on ham radio. Okay, so this is the card which has come from a Russian ham radio station and a research facility in Antarctica. Similarly, there are cards from US and from Canada, from Japan, as well as this is the one from Japan Antarctic station. Okay, so here this is the card that we exchange, we tend to collect over the course of this hobby, and for doing so we also get and the back of it we have the details of our contact. When was contact made, what was the time, then what frequency did we use to make these contacts. All those details are behind it. Also we also have some special call sign for India, which is AT. AT and AU are usually used for special event. Now today is a National Space Day, so there is a ham from Delhi who is operating a special ham radio station called Alpha Tango 23 Space, SPACE. It's a special call sign which we use to promote a National Space Day. So like this we have these call signs. Similarly, we also do some kind of experimentation with antennas and stuff like that. So we'll just get into like what bands that we use and with more details about the communication part.
We are surrounded by all sorts of invisible particles and waves. some of which are charged. And these moving charges result in electric and magnetic fields. When electric and magnetic fields couple with each other at a right angle, it results in the formation of electromagnetic waves. These waves travel in a direction which is perpendicular to both the fields. They travel through space at the speed of light, and just like light, electromagnetic waves can travel through a vacuum as well. Electromagnetic waves come in varying forms of frequency and amplitude. Even heat and light are forms of electromagnetic waves. Radio waves are part of the electromagnetic spectrum. The radio wave spectrum has a large range of radio waves, from maritime navigation signals used by ships, which are very low frequency, or VLF, to satellite signals, which are extremely high frequency, or EHF. In this presentation, we are going to focus on the HF, or high frequency radio waves, and how they are used in communications. The range of HF radio waves is between 3 to 30 megahertz, according to the electromagnetic spectrum. The typical range of modern HF radios is 1.6 to 30 megahertz. So how did we know about electromagnetic waves and radio waves? It all started with James Clerk Maxwell's treatise on electricity and magnetism in 1873. The first radio waves were detected 15 years later by Heinrich Rudolf Hertz, whose practical experiments supported Maxwell's theories. Heinrich's work inspired Guglielmo Marconi's early experiments with wireless telegraphy using Morse code. In 1901, Marconi successfully demonstrated wireless communication from Cornwall, England to Newfoundland, Canada, a distance of 3,000 kilometres. So the radio waves that Marconi used were the high frequency, or the HF radio waves. How does HF radio technology work? A transmitting antenna, shown as TX, emits the HF radio waves, and a receiving antenna, shown as RX, receives these radio waves. There are three types of HF radio waves. Ground wave, which is good for short distance communication at less than 20 kilometres. It follows the curvature of the Earth and is therefore attenuated. Direct wave, which can be used for long distance communication between ground stations and aircraft. And finally, skywave, which uses the ionosphere to refract the signal back to Earth at varying angles, providing long distance communications. As you can see, skywave covers the maximum distance. We are most interested in skywave to propagate signals. A layer in the atmosphere called the ionosphere refract the HF radio waves, making this technology work over long distance. The angle of the antenna is responsible for the coverage area as it aims the radio waves which are bounced off the ionosphere. This also creates a skip zone, where the ground wave ends and the skywave starts, where the radio waves are not present as they are not refracted into this area. To reduce or overcome a skip zone, the takeoff angle of the antenna is adjusted. By using a higher takeoff angle for the HF signal, the ionosphere is used to refract the signal back to Earth at a shorter distance. All sorts of voice, data, or signals can be sent using these waves. The ionosphere itself is made of several different layers that refract the HF radio waves in different ways. These range from the closest layer that exists in the day, called layer D, to the farthest layer called F2. These different layers behave differently in the way that they refract HF radio waves. The D layer in particular can weaken or attenuate the HF radio waves, as it contains a higher number of charged particles due to the sunlight. The most common layers used for signal propagation are the F1 and F2. These layers change between day and night. A basic rule for HF radio signals is to use higher frequency radio waves during the day, as higher frequency waves will travel further using the ionosphere. The higher the sun, the higher the frequency required. The higher the frequency, the longer the distance the HF radio waves will travel. What are some of the other factors that can affect HF radio waves? Solar flares can alter the refracting property of the ionosphere. 11-year solar cycles can either hinder or improve the HF radio waves. And finally, something man-made, such as power stations which produce electrical noise, can affect the reception of HF signals. Apart from these factors, communication through HF radio waves depends on a few other things, like location, local radio rules and regulations, planning for the frequency sets to be used. So if you have the right antenna and these factors covered, you are on your way in the world of reliable long-distance HF radio communication.
So as you can see, because of ionosphere, now ham radio we involve communicating over various bands like HF, VHF, UHF. I'll come to those parts. But because of the ionosphere and the signals getting bounced off this ionosphere, we can make contacts all around the world using ham radio and very less power. This is the same reason why you can hear BBC radios from UK in Goa, and you can listen to all the AM stations around the world on your shortwave radio that you may have at your home. Now coming to HF and VHF. Now HF stands for high frequency, which is from 3 to 30 megahertz. VHF is very high frequency, between 30 to 300 megahertz, and UHF is from 300 to 3 gigahertz. Now the thing is, VHF and UHF, they are not reflected by ionosphere generally. They get passed through the ionosphere. Hence you cannot use this kind of mode of propagation for communication. So this gets limited to only line of sight communication. Now what you see here is a VHF UHF transmitter and receiver in a single device, and this is the antenna that we use for communication along with this kind of antennas. So this antenna is similar to what you used to have earlier for a TV signals, not the dish ones, but the earlier time when we used DD1 and all, those were in the VHF bands, and we used to use such kind of antennas on our roof to point them towards the Panjim Duration Kendra. Like most of you must have known, I know the new generation will know about the dish antennas. Same with dish antenna also. Dish antenna usually are in the SHF bands, that is super high frequency or EHF bands. So those are for satellite to communication. So they are also, rather than pointing your antenna towards the transmitting station, you will point it towards the satellite, because that will give a higher coverage all over the country. Okay, so we use VHF for earth to space communication, space to earth communication, because there are ham radio satellites as well. Those are used for ham radio communication, because there are many colleges and universities that experiment with satellites, and they use ham radio bands for communication. So similarly, your older television signals, they were using VHF for communication. Now coming to VHF. Now as I said, VHF cannot be reflected by the ionosphere. So what do you do when you have obstructions between the two stations? Like for example, if you are in Kanpur and I am in Madgaon, you cannot make direct communication over VHF because there is a big Karmal Ghat mountains in between. So in such a scenario, we use something called as a repeater. Repeaters basically are used. That is, whatever you transmit is first received by the repeater, and the repeater will retransmit on a different frequency. So the person on the other end will be able to communicate with you. Similar repeaters are used not just only for ham radio, but they are also used by police or any other authorities to increase the coverage on VHF and UHF bands. Repeater is a general concept. It is applied everywhere. Even your cell towers, they use repeaters to increase your coverage in a given area. Now let's go to different kinds of activities that you can do as a ham radio operator or as a ham radio, or what we call as a shortwave listener, or ham radio operator who has not got license. Okay, we call them SWL, shortwave listener. Although shortwave is an older term, you can say a radio listener as well. Okay, so what do? We can use Morse code for communication. Yes, Morse is still used as a part of communication in ham radio. It is basically sending alphabets and numbers and some characters using combination of dot and dash, or dit or da. Okay, how many of you have seen movie Razi here? Okay, so or any other movie where they have shown Morse communication. You might even see it some English movie, but Razi was that is the one that came to my mind. Like, so we use Morse code for communication with other ham radio operators. Of course, this is only limited to alphanumeric only. You cannot send images or something through this. Will come like I'll show you how you can even send images through ham radio operators, through ham radio equipment. Okay. Then we also have something called as voice communication. So here you can see the communication happening between two ham radio operators. One was Sandesh and other one was from Russia. So as you can see, we were not using the alphabets like V, U, 3. We were using something called as phonetics. Phonetics is basically you use alphabets like most of you must have seen in movies like Alpha Tango, talking, something like that. In some military movies you must have seen. So they are basically, we use like when you are talking on phone also, if you are telling somebody your address and you are telling that B, A, something like that, then there is a possibility that B might be heard as D, right? I mean, most of you must have that experience where your alphabets were heard wrong. So instead of that, we use something called as phonetics, where A for alpha, B for Bravo, C for Charlie. So this alphabet that we use. So when I am telling my call sign over radio, I will use Victor Uniform 2 Yankee Quebec. YQ is Yankee Quebec. Similarly, we use this phonetics because when we make contact, sometimes the signals are strong, sometimes they are not strong. So we have to make out the signal through the noise. Because we are not using very high power transmitters. These are not commercial, like although this was a commercial radio, but we are not using very high power like your FM stations or your AM stations. We are using very limited power like 100 watt, 200 watt, less than the power that your geyser consumes at your home. So this like that is the level of power that we use when we communicate. So we use these alphabets, phonetics for communication purposes. Like so now what we saw CW, we saw Morse communication. Now with advance of computers and because of the increase in the speed of computers and due to lot of processing power increase, there is something called as digital communication as well. So digital communication is very simple concept wherein you will encode your message into a tone using a computer and you transmit that tone over the radio. Okay. And then the signal is received by the other end and decoded by their computer. Okay, like it is computer to computer communication, but there is no internet involved. It is purely through radio waves from one person to other. Now in all this, one important part that you should know is that we are not reliably relying on any other third party. For your mobile phones, you will be dependent upon your Geo towers, right? So if what happens if the Geo tower is off, network will go. You cannot make contacts. It is not like with ham radio. Ham radio is peer to peer or one person to other. There is no dependency on anybody else. What we transmit is received by other person. Now your question will be how the other person will know that I am on this frequency or how the other person will know that I am listening to you. So in ham radio, government has given us some bands which are only allocated for ham radio operations. Like for example, in your car, you will see your FM changing from 88 to 108 megahertz, right? You know that between these frequency only you will be able to hear FM stations around India or anywhere else. It is the same band that is given all over the world. You cannot go beyond that because beyond that the frequency is allocated for some other purposes, like for aircraft. Aircraft operations happen from 110 megahertz to 130 megahertz or so. It is only for aircraft. So like these divisions are there. So for us also, we have been given bands in various ham radio across the radio spectrum for communication. So when I know that I want to operate my radio, I will be always looking for other ham radio operators in those bands only, because radio spectrum is really wide, but we are limited to ham radio operations only. So this way we know that somebody will be there trying to communicate with you in those bands. Okay, so this is one of the mode of communication where we use digital mode, that is computer to computer without internet, through radio, and no third party involved for communication purposes. Now these three things happen are with respect to ham radio operation, where you have a license to transmit. Okay, now let's say you don't have a license, then what can you do? Now without a license, you can own something called as a RTL SDR dongle. Okay, so this is a small radio receiver, just like a pen drive, that can receive from 25 megahertz to 1.3 gigahertz. So it opens ham radio bands and as well as some satellite bands for you. Okay, this is a very simple ham radio radio receiver that can be used, which can be connected to your laptop or even your phone, and you can receive radio signals. For this you don't require any license as such. Okay, I'll show you the demo of this during our demonstration part. So what can you do with this? I'll come to this in a short while. So you can do things like you can receive images from astronauts. Now you know International Space Station, right? And you know there are at least 3 astronauts in space at a given time. Right now there are more. Okay, so periodically, just like we have our National Space Day today, whenever there is an international activity like International Cosmonauts Day or some important events about astronomy or science or of space technology, they will celebrate this by sending images from space. These are the images that I had received from International Space Station. These images are sent by astronauts from the ham radio transmitter that is there on the International Space Station. So you can even make contacts with them whenever they are free. I mean, there are hams in India who have made contact with them, although it's a bit rare, but you can make. These are the images that they had sent during the 20th anniversary of International Space Station itself. So these are 2 images. So for a period of 3-4 days, they will keep on transmitting. And whenever the International Space Station will pass over you, you can use an antenna like this or a simple antenna and a dongle like that to receive the images sent by them. What else you can do? You can even, there are some weather satellites which are open for public to receive images. So you can use the same dongle and a laptop to receive these images of weather images. Like for example, that is the image of cyclone Fanny that was in 2019 or something, and such various other images. So you can get these live images from the satellites. Okay, now coming to our ham radio operations, how does our radio station look like? So these are the 2 images. One in where this Sandesh station where he is using commercial radios for communication. The other one are all homemade radios. That you can see this is a radio that is made by me, which you can make it yourself as well for HF communication. So you can make a radio like this using a circuits and component that is available, and nowadays because of internet it is easier to procure things online. Okay, then you can even build your own antennas at your home for radio communication. I guess all the hams in Goa, we are building our own antennas for our ham radio communication. Okay, we build our own antennas for HF, VHF or UHF communications. Then you can build your antennas, you can build your radios. Here is a radio, here is a video of an antenna rotator which was made by Sandesh using on hobby parts. So the antenna will rotate to improve your signal reception, and this is all through mobile control. Okay, now what is satellite communication? Now, being Space Day, welcome to this topic wherein we have something called as satellite communication. In ham radio as well, we have satellite communication wherein there are ham radio satellites that can be used to make contacts all around the world. Okay. Now, as I said, with VHF, you are limited with line of sight. If somebody is on the hill, he can maybe increase his coverage area. But imagine if you put a same radio repeater in space, then the coverage will be like covering half of the India, right? Because you have a larger view from the top. So same concept is used for ham radio satellites, where they will use ham radio repeaters on a satellite for communication to improve the coverage. Okay, and these ham radio satellites, they are sent by students from schools and colleges, just like you. I mean, they are not built commercially, like at least most of them, they are not built commercially. They are all something called as CubeSats or PicoSats, which are sent by students of colleges, schools and universities, and they do experiments other than ham radio repeater. They also do other kind of experiments through these satellites. Now here we have a communication that we were doing through International Space Station. So, and the other side we have a dish antenna for communication over a geostationary satellite for ham radio communication. Apart from the receiving weather images and SSTV images, you can even set up your own satellite tracking station, where you can track the data or the telemetry coming from various ham radio satellites as well. Like, you will be helping the community with your station to collect the data from their own satellites. Like, how many of you know about SETI program, SETI, where you dedicate your computer to find signals of any extraterrestrial beings. Like, there is the radio telescopes around the world that collect the data, but they don't have capabilities to process the data. So they will send this data over internet to various collaborators like citizen scientists, and you use a computer to go through the data and find out whether you have seen any extraterrestrial signal in that. In similar way, SatNox is where you set up your own ground station and you connect it to the internet, so that you can collect the data from various ham radio satellites and publish this data on the cloud, where the satellite creators can use it to talk to the satellites and also get health of that satellite. Along with this, we have something called as TinyGS station, wherein which will show a demo shortly, where just like SatNox, we have something LoRa based satellites which can be used for communication. So you set up your own station to receive the telemetry packets from these LoRa based satellites. Now this is the one which is continuously run by Mahendra at his home. So we keep our stations online all the time to collect the data and the health from these satellites. So these are the list of all the satellites, which is blue in color, and green are all the stations around the world which are receiving these signals. Now coming to who can be ham radio operators. Anyone with interest in this hobby can be a ham radio operator, given that minimum age is 12 years of years. Okay, you don't have to be especially from any technical background to be from ham radio operators. We have some doctors, lawyers, engineers, then accountants who are then management people like Sandesh, who is from management background but is an ham radio operator. So like this, anyone with various backgrounds can be a ham radio operator. One of the current usage of ham radio operators is for disaster management, wherein whenever there is any natural calamity, you know that a communication is the first victim of this calamity. So you have to provide some kind of communication. So ham radio is used for communication with these affected sites. So like there will be a group of team of ham radio operators they will go there and they will communicate with the magistrate, and you can communicate with these stations. Okay, they provide help during calamity, like recently during Wayanad landslide, communication was down, road access was also out. So some ham radio operators managed to get to ground zero and provide communication help to get medicine or food or whatever from the affected area to the headquarters, so that the communication can be utilized. So even in today's era, where we have 5G, 4G and all those things, they are insufficient they are not of any use when there is a communication breakdown. In such cases, we use ham radio operations for providing communication backup. Now you have to answer an examination for getting into ham radio. Now this examination does two things. One is it checks your technical know-how, and second is it also tells you about the legal aspects of the ham radio. Now, for example, if you have gone for any driving test, then you have to, the first test is a learner's test, where you have to learn the rules of the road, the lane discipline, right hand turn, whatever, and you have to answer that exam, right? So similarly, here also you have to learn rules and regulations to operate a ham radio station, because it is important that you only operate within your band and you do not cause any interference outside the band. So this is why you have to answer technical. Technical is basically very simple question and answers, where it is like simple, very basics of electronics and radio communication, not like engineering studies as well. If you already have a degree in engineering, then you can skip technical part of the examination. Then there are various bands that we can operate in for ham radio, and we have two types of license: restricted grade and general grade. So it is like with restricted grade, apart from you are only answer the multiple objective questions for an exam. If you clear 50%, you get the license. In general grade, apart from the written examination, you would also answer Morse code test, which is 8 words per minute. So you can upgrade yourself with general grade later as well. Like you can enter the hobby with restricted grade, and then once you learn Morse code, you can upgrade to general grade. General grade just gives you higher flexibility to get more power for communication and higher modes for communication. Okay, so any questions so far? So maybe we'll start with our demonstration here.